Hazel. Hazel. Hazel is a game engine that I've been working on for quite a while. See, I feel like I have to say that because it's been so long since I made a video about it. And to be honest, it's been a while since I've been able to actually sit down and work on Hazel consistently. And I feel like that's making me a little bit depressed. Because Hazel is like my baby. I want to keep working on it. Does it make sense? Why would I keep working on a baby? Anyway, I want to keep working on Hazel a bit more. And lately I've been focusing a little bit more on other projects, other YouTube videos. So this is me trying to basically be like, guys, I'm going to get back to Hazel. And I sincerely hope that I do. If you do ever want to see in general what's going on with Hazel, what the team's working on, what we have planned, then just go to hazelengine.com, click on this Millernote board button, and then that will take you to this Millernote board where you can see what we're currently working on. You can just double click on these little squares and it'll take you to the appropriate page. You can see what's planned for that feature and when the estimated release is, as well as future features that we have planned. And then there's also some general information as well, like these docs and the team. Second of all, you may have noticed this video does not have a sponsor. If you would like to support my channel and Hazel, the best way to do that is to go to patreon.com/thecherno. If you sign up for the $10 tier, then you'll get access to Hazel immediately just by going to get.hazelengine.com and connecting your Patreon and GitHub accounts. Thank you, as always, for your support. And finally, if you are interested in working on Hazel as a volunteer, whether that be just to help out for fun because you think you could bring something to the table, or maybe you want to actually get some experience working on a game engine, in the description below there will be a link to a form. Fill that out and hopefully we can work together. And finally, did I already say finally? I feel like, as always, I haven't really been communicating the Hazel work that I do end up doing. I mean, I'm making this video, so that's a good start. I used to do a lot more live streams. I've kind of stopped doing them just because my schedule is a little bit sporadic at the moment. What's the best way for me to communicate what I'm doing with you so that you can keep up to date with things? Should I do more live streams? Should I try and edit live streams into little devlogs? Are little videos like this more helpful to you? Let me know in the comment section below. So this video, I wanted to share a little bit about what I have been working on when I have had time to work on it, but also what some other members of the team have been doing, specifically 0x, aka Jim. He's basically responsible for the entire animation system in Hazel. He made it. And the last time we really did anything animation related was when we tried to recreate Genesis, the first game that I ever made, but in 3D using Hazel. It's kind of an ongoing project in the background. I'll have the latest video to that linked up there. So that Genesis 3D remake, I decided to make it an MMO. I decided to make it multiplayer because I thought that would be more fun. To be honest, that was surprisingly not very difficult, at least to get to the state where we had multiple players, multiple clients connected to a central server. Even though that involved introducing networking and multiplayer concepts to Hazel for the first time, it went pretty well, to be honest, minus some Linux issues, as expected. But the part that was like kind of challenging, I think, for us was the whole concept of animation, skeletal animation in a networked multiplayer game. And so that's really what Jim has been doing for like the past few months in his spare time. He's a volunteer on Hazel. I think he's been making pretty good progress. You can see that basically animation is working across multiple clients here. Basically what's happening is it's just sending like a trigger for an animation, and then that animation is being played on the client. But Jim has also introduced this concept of client prediction. So basically clients can predict what other clients, what other animations, remote animations might actually do, because that will result in just a smoother animation experience. You can see here like the before and after. Before any kind of client prediction, and then with client prediction. The difference is huge. And then there's me. What have I been working on? Well, I'm right in the middle of making a new renderer. Of course I am. Renderer 2025. Renderer 2025 is basically moving Hazel's renderer into a completely new backend called NVRHI, NVIDIA Rendering Hardware Interface. Basically what that means is that instead of us having to handle the renderer API abstraction ourselves, we can actually delegate it into NVIDIA's third-party library, which effectively just makes our job a lot easier, specifically my job, because instead of having to maintain multiple render API backends, add more in the future, keep up with all of the new Vulkan specs that are coming out, stuff like that, I can just delegate that to NVIDIA. I can just let them handle it, and I can just implement their library instead. Two frequently asked questions to do with that. Yes, it is completely open source, which means that if I need to add something else like Metal, I can do that. And also, yes, of course, it works on AMD and Intel GPUs. It's just using Vulkan and DirectX 12 and DirectX 11, it's not some custom like NVIDIA only code. It's just using those render APIs, which of course work with different GPU vendors. Here it is on GitHub. I'll have a link to it in the description below. Let me know if you want to see specific videos on how to use it and how to maybe get it up and running in a sandbox or something. I think I'm probably going to end up making videos like that in the future. Leave a comment below. All right, let me show you my work in progress of this new renderer. Now, at the moment, I am right in the thick of things. I'm like in the middle of this. Nothing works yet, but as I mentioned, I wanted to give you guys an update and maybe show like a little bit more of a realistic example of what this work is actually like. So the first thing that I want to show you is how Hazel's current renderer works and how it deals with different rendering APIs such as Vulkan and anything else. So basically, over here inside Hazel, we have this like renderer folder, right? And then we have a whole bunch of various classes, you know, like pipeline, texture, uniform buffer, vertex buffer. These are all generic versions of like renderer concepts, right? So if we have a look at pipeline as an example, you can see that the purpose of this class is to basically represent a pipeline, like in Vulkan, however, in a generic sense. So you can see that there's no actual Vulkan code here. We have a whole bunch of generic stuff here that applies to any render API, but what it really does is it just defines like what a pipeline actually is. So it's not the implementation whatsoever of how all of this is actually like realized into physical code. It's just like the high level concept, the abstraction over that. And you can see that with this pipeline class here specifically, it's basically like an interface. It's like a pure virtual class. We have a bunch of virtual functions with equals 0 here. They're pure virtual. They have to be implemented by a derived class. And then over here, we have a static create function, which will create a pipeline. And then you can see here, there are currently two options. There's none and there's Vulkan. Now, none is used for headless builds. So sometimes we build a version of Hazel without any rendering API. So that would be used, for example, if you want to run Hazel on a server. And Vulkan is currently the only render API that Hazel supports. It used to support OpenGL as well. However, when the Vulkan renderer started getting a little bit more advanced, we realized that it would be very difficult to support both, and we really had no reason to support OpenGL, so we cut that out completely. However, because we did support both, and my plan going forward was always to support DirectX and potentially other APIs as well. Like if we want to ship on a console, we might need to support something else. If we want to ship on macOS natively, we'd have to support Metal. It was never really an option for me to design Hazel's renderer in a way that was specific to like a single rendering API. I was always conscious of like the design and architecture to be able to support more than one. So if Vulkan is in fact the current render API, and you can see by the way, this is a runtime switch as well, so you can actually compile Hazel with all of the rendering APIs that you want, and then actually select which one you want to use at runtime. So if it is Vulkan, then we'll actually create something called a Vulkan pipeline. And a Vulkan pipeline is a class that is derived from pipeline, is a subclass of the generic pipeline, which actually implements all of the functions that it needs to, all the pure virtual functions, but it also includes all of the Vulkan specific things that kind of realize this description of a pipeline into an actual implementation. So over here inside invalidate is where we'll actually go through and create the Vulkan pipeline. And this might be familiar to those of you who know Vulkan, or to those who are currently going through my C++ 3 multiplayer game from scratch series, because we've just been talking about pipelines. Now, since all of like this Vulkan specific code is also isolated to Vulkan pipeline, and if we go out to the generic pipeline, you can see it doesn't really have any of that. I mean, sure, you can get objects like a shader, which is also basically this generic thing that has Vulkan shader as the actual implementation that will contain way more stuff. If we are in a kind of Vulkan context, so for example, we have this Vulkan renderer class as well, which is just like a bunch of more or less high-level render commands like render static mesh, you can see that whilst it takes in a generic pipeline, we can grab that pipeline and we can actually cast it to a Vulkan pipeline safely, because we know that if we're inside the Vulkan renderer, obviously Vulkan is like the current render API, so therefore the pipeline object would be expected to also be Vulkan. And then we have access to that full Vulkan pipeline over here. We can do whatever we need, like get the exact like pipeline layout, which is the actual Vulkan handle, and use it in whatever Vulkan functions we need. The advantage of all of this is that inside the scene renderer, which is something that does not use Vulkan at all, so you can see in the includes that there's nothing here to do with Vulkan whatsoever, it is a generic class. I mean, I say generic class, I don't mean generic class, I just mean it's generic in the sense that it doesn't involve any specific render API, but its job is just to basically take in a scene and then just spit out an image, right? So it takes a scene and it renders an image. How does it do that rendering? Well, it does use a renderer. It does create like a whole bunch of different render passes. So you can see here, this is like the main PBR geometry pass. We're actually creating a pipeline over here. And then later from that pipeline, we're creating something called a render pass. Now this isn't like a Vulkan render pass. This is something I call a Hazel render pass, which is different. It's more of a high level concept that's actually supposed to represent an actual like render pass that happens on the GPU along with its associated data, as you can see. And then here it is being actually created and later, of course, used in render or begin render pass. So as you can see, all of this stuff that we're looking at here is generic in terms of which render API is used. That's like a backend detail that doesn't matter. The point is we've created a render pass, we're beginning a render pass, we're rendering a mesh with a material, or we're just doing render static mesh. We have like these pipelines, which are also generic in the sense that they don't specifically have to use Vulkan or anything. That's all abstracted away. That's all part of Hazel's render API rather than like Vulkan specifically. And this design, this architecture is obviously very important if you want to switch out that backend render API to be something else because you are shipping on a different platform. If you would like me to go into more detail about what you've seen here, like this scene renderer, Hazel's rendering situation, I haven't really made too many in-depth videos talking about this stuff. There are a couple exclusive to Patreon that I have made, but then the reason why I think I haven't talked about this stuff too in-depth is because in my mind, it's like I'm never really happy with the design. I know that it's like not the final design. There's still more work to do. There's still stuff I want to change, but you know, life's about the journey, not the destination. So maybe I should still make videos about this and share like my mistakes or my thoughts or why I think it doesn't work. Anyway, let me know in the comment section below. So everything I've shown you is from the net branch, which doesn't use this new renderer at all. If I go to the new renderer branch and we have a look at something like pipeline, I mean, pipeline I think still uses most of like the old stuff because I haven't really transitioned it just yet. But if we have a look at how we used to make the Vulkan pipeline, it was all just Vulkan code, as you can see. Now, if we take a look at the code, the new code that's still in Vulkan pipeline at the moment, but it will be moved out to just regular pipeline. I've made all these sections over here just to organize the code a little bit better, but you can see that all of this uses NVRHI now. So here is our graphics pipeline description, which is now coming from NVRHI. This is kind of similar to how inside pipeline we had a pipeline specification. It's basically like the same thing in a way, and we are actually going to keep Hazel's pipeline specification just because in case we decide to move away from NVRHI in the future or something like that, I still want us to use Hazel's render API because we obviously have more control over that. We can simplify it. We can actually create whatever code paths like we specifically want rather than just adopting everything NVRHI has to offer in the way that it's offering it as well. But here we're just going through and filling in everything that is inside this graphics pipeline description, which I'll show over here. So you can see it's got a bunch of shader handles, primitive types, render states, all of the stuff that you would expect to find like for a pipeline, depth stencil states, input layouts, blend states over here as well. So I've gone through and basically just translated everything from being like Vulkan specific here to just being NVRHI. It's as simple as that, based on the actual like specification stuff that we've set. Because Hazel, for example, actually allows you to set like, you know, different blend modes, and the frame buffer specification has a bunch of, this is all Hazel stuff, frame buffer attachment specifications, which have frame buffer texture specifications, which might have different blend settings and formats and all of that stuff, because we do end up doing like some moderately complicated like rendering stuff, and we need that level of granularity. So all of that's kind of been translated, and it's great to see that NVRHI supports all of these like semi-advanced use cases that we actually have, because if it didn't, then well, we couldn't exactly use it, or more realistically, we'd have to modify it and extend it to support our needs. And then finally, we create a graphics pipeline. So this is an NVRHI function, and then it's actually going to give us a graphics pipeline handle, which let me just write some code live here because apparently I forgot to set this. So we'll write handle equals that, and then I think this is for some reason private. Let's make it protected. This doesn't make any sense because I'm actually going to remove this Vulkan pipeline class, because obviously this is no longer a Vulkan pipeline. It's just an everything pipeline, because when we do actually run create graphics pipeline, this is where the new abstraction lies. So over here, you can see how many implementations of create graphics pipeline there are. There's one for DirectX 11, DirectX 12, and then Vulkan as well. So you can see if I click on the Vulkan graphics one, then over here inside that specific function, it's obviously going to call create graphics pipelines, which is going to be like the specific Vulkan function. So over here, we have all of like the different NVRHI libraries. Since Hazel uses premake, I had to go through and kind of translate a bit of the CMake into premake to make all of this stuff work, which was a little bit of a pain, but you can see we have all of these different static libraries, which they're all optional. You can just not compile and not link some of them. So on Linux, we obviously wouldn't link D3D11 and D3D12, just Vulkan. And then we have like the common one over here. So I've grouped all of that under dependencies and NVRHI. So to show you one more example, if we have a look at how vertex buffers work. So a vertex buffer is an example of like a renderer resource. So in the old Hazel, we had a vertex buffer, which this class you can see is just like an interface with a bunch of generic stuff as well. Inside the create function, we would check to see our current render API and create the appropriate one. In all cases, aside from headless, that would just be Vulkan. And then inside Vulkan vertex buffer is where we have the actual Vulkan stuff. Now, instead, if we have a look at just the vertex buffer class, so Vulkan vertex buffer isn't really used anymore. I haven't removed it obviously, but it's not used anymore. And inside just the normal vertex buffer class now is no longer like this interface sort of base class with pure virtual functions. Instead, it's actually got like the NVRHI buffer handle. And if we switch to the CPP file and look at the implementations, then obviously what we're doing here is just using NVRHI to actually create the buffer. So we've basically moved that abstraction from being at Hazel's level now, and we've offloaded it, we've delegated it to NVRHI. So that happens inside NVRHI under the hood. If we have a look quickly at how NVRHI is sort of initialized in the first place, so over here inside the window, we used to just create our own window using GLFW. We still do that, but it happens in something called a device manager. And a device manager will create either a D3D12, 11, or VK for Vulkan device. And without getting too deep into it, the device manager is now the thing that will actually create the window. And it will do so based on the NVRHI graphics API that we've picked, which you can see is Vulkan D3D12 or D3D11. Now, I'm not exactly sure how we're going to support headless builds with this yet. I haven't really considered that. It's interesting because the main like Hazel branch at the moment doesn't have any networking stuff that would require headless. And it also obviously doesn't have any of this new renderer stuff. So I'm kind of working on two projects simultaneously, and they're both pretty huge. So I am maybe slightly regretting this, but you know, hopefully by the end of this, we'll have networking and a new renderer, which is like great. The other downside is obviously the fact that, well, we don't support something like Metal. We don't support, I don't know, if we were shipping on PS5 or something, we'd probably want Sony's rendering API as well. What are we going to do with all of those? Well, it doesn't matter whatsoever, obviously, because we could just go through and add that ourselves. And it would be really not much different to if we had to add that stuff to Hazel anyway. It's just that we can do it at the NVRHI level. And obviously we have all of the source code like right over here inside the Hazel solution. If we didn't have this source code, if it was like closed source or something, we wouldn't be using this. It's as simple as that. But because it's all open source, it's supported by NVIDIA, it's written pretty well in my opinion, and it's definitely simple enough for me to understand. So coming in here and adding another NVRHI for like Metal, for example, would be completely fine. I mean, obviously it would be a lot of work, just like it would be if I was doing this within Hazel itself. Before we wrap up, the other advantage that I haven't quite touched on is the fact that NVRHI also has automatic tracking of resource states and barrier placements, which is optional, as well as tracking of resource usage and lifetime deferred and safe resource destruction. I mean, we do have deferred and safe resource destruction inside Hazel as well, because we kind of need to, but we don't have automatic tracking of resource states and barrier placement. That's all manual at the moment. And a lot of it isn't exactly specification adherent, which is why we have issues with AMD. In fact, if you take a look at Hazel's Milanote board, which I probably would have mentioned earlier in this video, if we have a look at the renderer 2025, then I've talked about a lot of this stuff over here as well. So take a look at this as well as all of these things that we are planning to do. I'll probably keep adding to this as I actually work through the project, but automatic resource tracking and state changes are obviously something that are planned. And then the other thing that's a little bit up in the air at the moment is the whole GLSL, HLSL shader situation. The reason why is because HLSL is a little bit more preferred generally, because with HLSL, you can compile that into SPIR-V so that Vulkan can actually use it, as well as DXIL for DirectX 12 and DXBC for DirectX 11, or D3D11, I should say. The problem with GLSL is that you can't compile GLSL into DXIL or DXBC. You have to basically cross-compile GLSL into HLSL first using something like SPIR-V Cross. So SPIR-V Cross is like this library that does a bunch of cross compilation. Well, actually, I think I didn't quite get that right. I think GLSL gets compiled into SPIR-V first, and then from SPIR-V, you can compile to readable, usable, and efficient HLSL, and then compile from HLSL into DXIL and DXBC if you want to support D3, D11, and 12. Now, we already have SPIR-V Cross sitting inside Hazel because we do use it for stuff like that. Hazel at the moment actually supports GLSL and HLSL, but because the DirectX like shader compiler does actually support compilation to SPIR-V directly from HLSL, but GLSL doesn't do the same for DXIL and DXBC, is getting a little bit confusing, I know. It kind of means that in a way it's more preferable for us to just use HLSL across the board, because then we just compile from that into everything instead of having to cross compile from GLSL into HLSL first to then support more stuff. I'm pretty comfortable with both shading languages. I guess I maybe have a little tiny bias towards GLSL just because I use it a little bit more on YouTube, and I think in some ways it can be a little simpler. But let me know what you think. Do you think Hazel should just not support GLSL at all and we should only support HLSL and then everything will be great? Or should we still continue to support GLSL? Because most of our shaders actually are written in GLSL. Some of them are HLSL, but most of them are GLSL. So should we still continue to support GLSL, or just drop it, keep things simple, and just support HLSL? Let me know in the comment section below. All right, I hope you guys enjoyed this little Hazel update video. As always, let me know what you want to see and what kind of format works best for you. And if you want to get access to Hazel and help support the project, then patreon.com/thecherno. Thank you all for watching. I'll see you next time. Goodbye.